Hello and welcome to the Vector Addition video tutorial. Here we have an inner tube that is being pulled upwards and to the right, downwards to the right, and being pushed to the right. And we're going to add up all of these vectors in both a qualitative and quantitative fashion. The first thing we're going to do is we're going to make a free body diagram. So we're going to copy and paste these three vectors over here, and this is our free body diagram right here over to the right. This is essentially showing all the forces the same way they are over here, just more organized, all acting on a single point. First, to determine the net force in a qualitative fashion, we're going to do what's called the tail to tip method. So what we're going to do is we're going to copy these again, and I just picked one at random. It doesn't have to be the top one. And then I'm just going to pick another one at random. And I'm going to place this vector so that it starts at the end of the last vector. Actually, when I slide these over, I can move them around as much as I want as long as I don't change their length or rotate them. And our last vector here, put it at the end of this one. So here are three vectors in tail to tip. And our net force start at the start and end at the end, right there. And just to show this one is different. So this right here is our final vector. So it's gonna, you notice these are like 40, 45, 50. This one's gonna be, I don't know, 120, something much bigger than 50. So there's about 50, 100, maybe 120. All right, now to do this in a quantitative fashion, so this is the qualitative answer right here, quantitative. What we're going to do is we're going to take the x components of all of these and add them up, and the y components of all of these and add them up. So we'll start with, say, the 50 vector, this one right here. So the 50 Newton vector is at a 30-degree angle, so we're going to need the x component and the y component. So the x component of this vector is equal to the magnitude, 50, times the cosine of our angle. And our y component for this is going to be equal to 50 times the sine of the angle. That's because the sine is equal to opposite over hypotenuse, and the cosine is equal to adjacent over hypotenuse. If I were to bring these 50s over, you would get your sine and cosine equations. So let's see, cosine 30, I'm using a calculator. 30 cosine times 50, so I get 43.3. And for this one, sine 30, I believe is 0.5. 30 sine, yep, 0.5 times 50, which should be 25 newtons. Okay, so that was this vector right here. Now I'm going to do this vector down here. So for that vector, we have a 12-degree angle, so the x is equal to 40 cosine of 12, and the y is equal to 40 times the sine of 12 degrees. So using a calculator, so 12 cosine times 40 gives me 39.13 newtons. And for this one here, 12 sine times 40 gives me 8.32 newtons. Now notice that both these vectors are moving to the right, so that's positive in the x direction. But this vector here is pointing down, so that's a negative y direction. So this answer here is actually a negative. All right. For this vector here, we don't have to break it into two parts because it's just moving to the right, so, or just pushing to the right. So that's it. Now we're just going to add everything up. So for our force in the x direction, we're going to take the 39.13 and we're going to add it to this one here, 43.3, plus we're going to add this, because this is x direction also, so 45 more newtons in the x direction. Whoops, there we go. So 39.13 plus 43.3 plus 45 is 127.43. And to determine our force in the y direction, we are going to add the 25, and we're going to add the negative 8.32. We're not going to add anything for this vector because this vector has no y component to it, this vector here. So 25 minus 8.32 is 16.68. So what we have here is we have a new triangle. We're going to have to flip that around. Alright, so we have our new triangle where this side of the triangle here is, where is it? Here, x, 127.43. So that's 127.43. And this side, the upside, is 16.68. Alright, so now we're just going to determine this, and we can use Pythagorean theorem to determine this. So 127.43 squared plus 16.68 squared is going to equal the hypotenuse, which is the resultant vector, squared. So 127.43 squared is a very big number, and 16.68 squared is 278.22, and that should equal the resultant squared. So I'm going to add those up. So 16238.4 plus 278.22, and then take the square root, and I get 128.5, which is right around what we predicted the net force would be. So I'm just going to change that result into force because that's our net force. We predicted that this right here would be about 120, and sure enough, 128.5. So looks like it works out. Thank you for watching the Vector Addition video tutorial.